A pen tester found every user's bcrypt hash sitting in the page's RSC payload. No API leaked it. A server component had passed the full DB user object as a prop to a client component. The article describes automatic RSC payload signing via Next.js signing key. In Next.js 14, this was an experimental feature requiring manual configuration. Starting with Next.js 15, signing is enabled by default and the environment variable is no longer needed. If you are on Next.js 14, ensure you set the key. On Next.js 15+, you can rely on the default behavior. The article mentions experimental taint object reference in the production incident, but does not show how to use it. This API prevents sensitive objects from being passed to client components by throwing an error at build time. Here's how to apply it to a user object. The article advises rate-limiting server actions, but does not provide a concrete pattern. In production, use a middleware or a library like it /rate-limit to prevent abuse. For example, wrap your server action with a rate limiter keyed by session ID or IP address to block excessive calls. Let's break down React Server Component Security, protecting RSC in Next.js, how it works, and the exact mistake behind that failure. React Server components shift rendering to the server, reducing client-side JavaScript and improving performance. But they also create new attack surfaces like data exposure and component injection. RSC executes exclusively on the server. The output is a serialized stream that the client parses. Next.js signs this payload to prevent tampering, but any data you select is serialized, so be careful what you fetch. Here's a simple server component that fetches a user and renders their name. Notice we explicitly select only the fields we need. If you accidentally include a password hash, it will be sent to the client. Server components can access server-side session data directly. Use cookies to read session tokens. This makes the component dynamic, ensuring auth checks run per request. This component reads the session cookie, validates it, and checks the user's role. If unauthorized, it redirects or shows an error. Always perform authorization checks per request. Any prop you pass to a client component becomes part of the client-side bundle. Always sanitize props and create a separate interface for client-safe data. Here we fetch the user, but only pass a safe subset to the client component. The email and password hash never leave the server. This prevents accidental data leaks. Server actions run on the server but can be called from client components. They are public endpoints, so you must authenticate, validate, and rate limit them. This server action validates input with ZOD, checks authentication, and creates a post. Note that we derive the authorid from the session, not from the client. Server components can read query parameters. Always validate them with a schema and use parameterized queries to prevent injection attacks. Here we validate the search query parameter with ZOD and use Prisma's parameterized query. Invalid input returns an error, preventing injection. Next.js caches RSC payloads. If you cache user-specific data, the next user might see it. Use dynamic functions to opt out of caching for authenticated pages. By setting dynamic to force dynamic, this page is never cached and always renders fresh per request. This prevents serving stale data to other users. Next.js signs the RSC payload with an HMAC. The client verifies this signature before parsing. If the payload is tampered with, it's rejected. Keep the signing key secret. RSC signing is enabled by default. You don't need to configure it, but you must ensure the signing key is set and kept secret. Server components can fetch internal services. If an attacker controls the URL, they could perform SSRF attacks. Always validate and restrict URLs. Here we use an enum to restrict endpoints. Only predefined endpoints are allowed, preventing SSRF attacks. Always fetch only the data you need. Handle errors gracefully and never expose internal error details to the client. This component fetches posts with a try-catch block. On error, it logs the error server-side and returns a generic message to the client. Environment variables without the next public prefix remain server-side. Use them for secrets, but never pass them to client components. Here, API key stays server-side, while Next public analytics ID is exposed to the client. Keep all secrets without the public prefix. Third-party libraries run on your server. A compromised library can steal secrets, audit dependencies, pin versions, and use a lockfill. Pinning versions reduces the risk of supply chain attacks. Always use a lockfill and run npm audit in CI. Monitor security events by logging authentication failures and validation errors. Use structured logging and set up alerts for unusual patterns. This middleware logs each request with metadata. Use similar logging in server components to track security events. This is the same issue we highlighted at the start. Here's exactly why that happened. A server component passed the entire user object, including password hash, as a prop to a client component. That prop was serialized into the RSC payload and sent to the browser. A server component passed the full DB user object, including password hash, as a prop to a client component, causing the password hash to be serialized into the browser's RSC payload. The fix is to pass only the exact fields the client needs. Use experimental taint object reference to make sensitive objects throw if they cross the boundary. Now the hash stays server-side. This is the exact mistake from the incident. Passing the full user object as a prop serializes all fields, including password hash, to the client. If you don't use dynamic functions like cookies, the page can be statically generated with a cached session, causing all users to see the same data. Using raw queries with user input can lead to SQL injection. Always use parameterized queries via Prisma or an ORM. To debug data leaks, inspect the RSC payload in the browser's Network tab. Add logging to trace what data is being passed to client components. Use lint rules to catch accidental exposure of sensitive fields. Let's run through some common interview questions. How do RSC prevent data leaks? Code stays server, only serialized data reaches client. What is the RSC payload signing? HMAC signature ensures integrity. Client verifies before parsing. How to secure server actions? Validate input with ZOD, authenticate via session, rate limit. And a few frequently asked questions. Can RSC access browser APIs? No, they run server-side only. How to prevent data leakage via props? Use explicit select and pass only safe fields. What is the RSC payload? Serialized stream of component tree and data, signed with HMAC. Let's recap the key takeaways. RSC code never reaches client. Control data serialization carefully. Use dynamic functions for auth. Validate input and sign payloads. Ready to go deeper? Up next. Next.js View Transitions, React 19.2 Native Animation Guide, and Next.js Monorepo with Turborpo, Enterprise Architecture. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.